Hello there, Vince here, and in this video today we're going to try to fix up various different items that have been sent into my PO box. This is my PO box here. If you have something interesting that you think might be good for a video, I can't guarantee it will be shown, it will not be returned, and it could be years before it is shown, so there's not much incentive, but still, the odd time things do drop into the PO box. So it's going to be a varied, random selection of different things. I am not a professional at this whatsoever. I just like to try very hard and use methodical thinking in order to try and fix stuff. But it's amazing what you can fix by just using your brain and just thinking things through. So without any further ado, let's get started. I hope you enjoyed the video. So here we have one of these lights that's supposed to activate by sound. I think it's got a load of different colour LEDs on it, and it's supposed to give like a party kind of atmosphere. Now, the terminals here are spotless. This whole thing looks immaculate. It says sound off and auto, and then this here is a little, like a volume wheel, but I believe it's to do with the sensitivity. So it's supposed to play if you've got pumping music. I think it's supposed to give the lights in time with the music. But look, if I make noises here, tap it around, it's not doing anything. If I go to auto, it's still not doing anything. And if I wiggle this wheel that way and in between, it's not doing anything. And it says here, Dear Vince, enclosed is the broken LED light we talked about over on Patreon. Feel free to take a look at your convenience, or never if you have more interesting projects. I also included some sugar-free sweets from Switzerland. I found them great for sore throats. Funny enough, I've already had two in about the space of 2 minutes, even though they're hard. Stuff like that, I can't help but bite into. Strange. Anyway, it says they're great for a sore throat. They remind me of tunes. I haven't had tunes in years, but you used to be able to get tunes, and if you can still get them or not. And do you remember lockets as well, with that kind of gooey honey stuff in the middle? But anyway, these remind me of tunes. I don't know if tunes are just a UK thing. Don't even know if they're still going. This probably won't make it in time for the holidays. It did. But anyway, Merry Christmas, a Happy New Year, and all the best all round for you and your family. Cheers from Switzerland, Attila. Hope I've pronounced that correctly. Well, thank you very much, Attila, and thanks for these as well. Let's open this up and see what's going on the inside. So I can see 5 screws around the back here. I can see that this screw is already partially undone. So I presume it's not just going to be something like a broken wire. Okay, so here are the LEDs. Red, blue, green, orange. Red, orange, green. I don't think I've seen orange LEDs before. Interesting. Okay, now, what is going on? I can see solder splats here. Weird. Yeah. Solder splats. So, voltage regulator. It looks like those legs are not soldered in properly. Okay. See here? So these unsoldered legs belong to the on and off switch, but it's more than just on and off. It's 3-way. There's off in the middle, you've got auto one side, and you've got sound on the other side. Now clearly Attila has already done some work on the switch, so I'm just going to take out the circuit board and just pop the switch out because it's already unsoldered. Interestingly, when I test it with continuity, I don't seem to be getting a reading across the pins where I think they should be. So I'm going to open up the switch itself, because the switch, although it's been unsoldered, it doesn't look like it's been opened before, so maybe there's corrosion inside. So let's now open up the switch and see what's happening on the inside to find out why there's no continuity. This doesn't look like it's been opened up. Now, what's happening here? What's happening here? Dirty, is it? This just sits on top and moves these along to connect up the different pins. Yeah, so you can see that that's going to be off. That's going to be in one position. That's going to be in another position. So that should no, so they don't connect up either side there because they're not bridged there. Now let's see here if it's connecting up. So this should be connected to here. How weird. Oh, it is. Is this connected to here? No, that one's not, and it should be. So that one is. That is, but that's not. Okay. Let's go into the next position. So that's going to be the off position. And it's going to be these two here. Yes. No. And now let's do this position. It's going to be these two. No. No. Is that right? Hold on. Oh no, sorry. Here and here. Nah, not there. Oh, there, and that's one of the on positions, isn't it? Or have I gone off there? 1 second. Bring that back a bit. There. No. No. Okay. Right, it's a faulty switch. So it looked like Attila nearly got there. I just don't think he took it apart to do the final testing on the inside. Let's give this a little bit of a scrape up. I think I'm going to put a little bit of deoxit on here. It does look a bit blackened, doesn't it? Yeah, look here, look how tarnished that is there, look. Well, there we have it, a faulty switch. So I'm just going to give it a scrape up and then use my beautiful deoxit. This time next year I will be sponsored by them. Why on earth would they sponsor me? Why would they spend money on me when all I do is sing and shout their praises? I must be a dream come true to them. Really, I'm a deoxit mug, aren't I? Because I should be getting paid for saying how good they are. It's just that everything that they make just seems to be amazing. Expensive, but amazing. So anyway, yeah, scrape all this up, put deoxit all over it, and then it's continuity-wise is testing okay again. So we solder it back into the board, and it should be working, shouldn't it? It should be working, shouldn't it? An item like this shouldn't have more than one fault. But then again, it is a My Mate Vince video. Right, can anybody spot the mistake I made? A few of you have, haven't you? The switch should be on this side, and I should have soldered this side here. So now I've got to unsolder it, pull it out and pop it in the other way. I was thinking that the pads weren't flowing very nicely. Well, it has been a long day, but that's a classic My Mate Vince. Anyway, I unsolder, pull the switch out. Annoyingly, when I pull it out, I do pull a pad, but it's no biggie. It only rips, it's only a millimetre or two, so I just have to run a little bit of wire to repair that. So let's pick the video up when I've got the switch in the correct side with the little pad repair done. And then let's turn it on. And this should work, shouldn't it? Because we had a faulty switch, and now the switch is no longer faulty because it's been scraped back and deoxit has been added. So we should see this come to life. Right, so that's it there now, and they are all soldered up. In fact, that one's not doing anything, that one's not doing anything, I don't think. But that one is, that one is, that one is, that one is, and that's the one I just repaired there. Yep. Right, let's put the screws back in and see if it's going to come to life. I won't put it fully back together yet. Okay, here goes. Surely it has to work. Now, where are we? Sound. Oh my word, come on. Auto. What?
Ha ha.
You being serious? Ah, come on. We fixed the switch. Can't have two faults. This thing's too new. Right, let's have a look. Right, we are going from here. That's the one I repaired, 6.1 volts. And now it's going to be coming through to here, 5.8 volts. You coming up to here? Yes, you are, 5.6. Oh, hold on, you're coming up to here though. 1 second, let's go over to auto. Yeah, 5.9. So what follows is about half an hour of keeping my negative lead on the negative and trying to chase the voltage round the board with my positive. But what I didn't trace was the negative. So basically everywhere that I put the positive, it was getting there. And it was only after about half an hour I thought, well, what's the negative doing? And let's pick up the video now when I start tracing the negative. But this has taken me a long time to get to this stage. It's been heavily edited because of the nature of this particular video where I'm doing numerous items in one video. But yeah, really struggled on this one here because I was just hell-bent on following the positive voltage around the place. I didn't think about moving my negative lead. Right, now I've been following the positive through, yeah? And we know that the positive goes into the switch. And we know the switch is now switching because every single time I, put it to where it needs to go, it is switching across, yeah? Look, the negative, yeah? The negative goes here and here. When we turn it over, it goes, right, so this is just like a test point, yeah? This goes to here, it goes all the way up here, all the way along, all the way, and look, it goes to here. I'm now wondering if it's some issue with this thing, because when we plug in something into here, I've just got a little jack here, it should then, if we're putting power into here, you don't want it going back into the batteries. So let's see now what's going on. So when we do this, it should kill it going back here, shouldn't it? Now, it should kill it going back there. If we take it out, there should be some difference, should there not? So right now, we haven't got anything there. Yeah? When we plug this in, have we got anything here? No, so 1 second. This goes to here. Yeah? So that means the outer one goes to this one at the bottom here. The outer one goes to here. Yeah? But surely, should it not go to here now as well? Yes, it should. Time for a Vinci drawing to try to explain what I can't put into words. Right, you're not going to be able to see it because it's so small, but basically this is where the negative from the battery goes, and this here is the negative. Sorry, yeah, this is the positive from the power supply, this is the negative from the power supply, and this here is the negative from the battery. And you can just see the negative from the battery is at the very bottom there, and when you plug the jack in, it should basically break it from that back bit. Let me get a bit of paper because you can't see that. So if we have this here, on the inside what we're going to have is, this is going to be the positive, and this here is the negative from the battery, and basically here if you can imagine, this comes up and rests on here. This is the negative from the power supply, yeah? So what should happen is, when nothing's plugged in, this should be touching this. And then, I've got this wrong, haven't I? Oh, annoying. I'll tell you what it is. Let me start again. Positive. This is the negative from the battery. And then this is basically the negative from the power supply. Then when we plug the jack in here, it forces this downwards, yeah? So then this goes down here. So you can see it no longer contacts this part here, yeah? So when you plug a jack in, it can't go back to the batteries. but obviously it's not making a contact, is it? So if we go into continuity, we should when there's nothing plugged in. In fact, we've got it now, look, we've got it there now. And then when we plug this in, it's going to break these contacts. Yeah, it's broken those contacts there. Yeah. So let's just double check. That's the middle one. And not anywhere else. And now that's there, but not here. Yeah? Right, unplug again. It's working now. It's working now. That wasn't working before. Let's solder that back in. Let's see now. Maybe just the very fact of unsoldering it has put a bit of heat in and cleaned it up. Well, this thing was such a tease. So I put it back in and it wasn't working. Unsoldered it and it was working. Basically, we're talking it must be just a fraction of a millimetre loose on the inside. Maybe it's not the best made jack and there's a little bit of play on the inside. And it meant that every time I soldered it in, it was just enough for the contacts not to contact. So it needs a new jack. But what I've done is, to try it to fix it, I've completely melted a big hole in the bottom of it with my soldering iron, and then I physically forced it up. And in order, and by melting a big hole, what I've probably actually done is melted the plastic more around the metal contacts to take away the play. Anyway, long story short, I'm not going to try it 1,000 times because life's too short, but I tried it about 10 times, and every time I plug the jack in, it breaks the contact. Every time I unplug the jack, it makes the contact. So now we're going to solder it in, and hopefully now, at long last, it will be working. I know I've edited this video down to a short amount, but just to let you know, I had 1.5 hours of footage on this one here, so it was quite challenging for me. I know, I just can't believe I've come across these jacks before. I should have known, but yeah, I was just too busy focusing on the positive and not the negative, so lesson learnt there. Okay, let's put it on sound, and there we go. Oh, doesn't that look lovely? Ooh, tell you what, let's turn off the lights so it's is a bit more bright. There we go. Look at that. Fantastic. So now let's put the jack in. There's no power in it at the moment, but let's just put the jack in. Please work when I pull it out. Pull it out. Yes, it's still working. Brilliant. Now let's put the bench power supply on. I'm going to have to put the lights back on for this. And let's get the, let's put in 7.5 volts and see if it starts working on the auto. So we're going to plug it in now. Stops working on that one there, and then go over to auto, and now it's working there. Brilliant. I think it's better on sound anyway. Oh yes, it's working. Yes. Okay. Is that jack going to be a reliable fix? No. But then again, maybe the jack isn't the best quality in the first place. But I enjoyed that one. I found it very challenging. The only reason I really enjoyed it is because I got it working at the end. I need to remember, whenever you see one of those barrel jacks and you also have batteries, it's always going to be a point to check, because I've had that quite a few times in the past now, because you see, you don't want to be able to put power from that back into the batteries, because then you're going to be charging up these batteries which are not chargeable. So it's like a safety thing, and it has failed many times in the past. I love that. It reminds me a little bit of Knight Rider, even though it's not going left to right. It looks actually quite futuristic. It's pretty cool. Massive thank you to Attila for sending this out to me, and I hope you enjoyed that fix. So on this one here, we're going to be attempting to fix up a Raspberry Pi. This one is a 3B, and it says, "Hi Vince, I apologise about the handwriting. Not going to lie, your writing is neater than mine. Today I've got you a Pi 3B with advertised no video. Surprisingly, it worked first time for me, but the power isn't stable. Looks like a dodgy port. I no longer have the PSU. Sorry, no problem. I attempted to clean, but no luck. I'm looking to get into soldering, but I have no time at the moment. I've also got some Steam links with no life if you're interested. Thanks, Jake." Well, thank you, Jake, but I've already done Steam links. I like to mix things up on the channel a bit. So, yeah, no, I won't take any more Steam links links. Thank you for the content. I only found your channel about 1 month ago and I love it. Thanks again. Well, that's great. It's lovely to know that my channel is still being discovered. And here is the Raspberry Pi. Now I had a little look at this and I can see lots of corrosion down here and also on this bit here. So you can display out to a TV here, but this is also a display connector here if you want to kind of put a screen, you know, sandwich a screen on top, and there's corrosion on that. So I think this is all corrosion based. Let me zoom in and show you. So if you don't know, this is just one of those tiny little Raspberry Pis. It's just basically, if you can imagine, a tiny little computer. And check this out. Look here. Look at this display here, and this is all crusty. Here, look at that, all furry and corroded, and it looks like some kind of liquid damage has happened here. Also, the port, HDMI port, looks a little bit iffy here, and the inside, I can see corrosion deep down there on the inside as well. There you go, you can see it there, and yeah, just at that bottom bit there. And look at this here, is awful. Look at it all around here. All these legs of these chips are just, they're just look at the crust in between the resistors there. So although it looks awful now, this is where isopropyl alcohol is just amazing, because I'm just going to brush over that and you will suddenly see it will start to look much, much better. I can see corrosion here, here on all these anchor points. But the chips themselves, I think, look okay. Is that corrosion here? Yeah, a little bit of corrosion there as well. Right, so I'm going to get my gloves on. I'm going to give the board a good going over with some isopropyl alcohol. And then let's do some reflowing. And hopefully that will sort out the power issues and also the display issues. This thing here is clearly going to be intermittent. It may work, but then you can see some bit of corrosion may happen here and then it will stop working. Let's get rid of this and hopefully this Raspberry Pi will then be working again. This here is the wonder stuff, 99.9%. Got loads there. Let's give it a nice generous helping. Got my flux brush. Now let's zoom right in and you'll see bit by bit it will just start to look amazing. But then when it dries up it will look bad again, but not as bad as it does now. So there's lots of scrubbing to do here, so while we're doing that, sit back, relax, and I'll shout out the My Mate Vince Massive. The members this month are kitdigital.com, Kip Hakes, Max Rokatansky, Chris Seal, Felipe at MrKeebs.com, DJVG, Pigsy, Anthony Dean, Bazza2, Russ Melanson, Gaspar Heller, Rickard Bergland, and Soul Reaver 555. Thank you so very, very much. Now I'm not sure what these are for, but if they were something like voltage regulators, then you can see that they're very, very corroded. But they might not be, maybe they're purely to do with their headphone jack or some sort of audio. Now I think what I'm going to do is I'm going to get some hot air and I'm going to get a load of flux, and I'm just going to try to heat up the flux around this area, also here as well. And I think this will be okay. I might add a little bit here as well. And loads around here. Let's get the hot air on it. Hopefully that will help clean it. Now I don't want to melt this connector, so I just got to be a little bit careful. I'm just going to kind of put it more towards the board rather than the connector. Right, now I'm going to get my soldering iron on them. And I'm just going to reflow these few here. You can see the black coming off, you see. There we go. I don't care if they don't look as good as they did when they left the factory, as long as the corrosion's gone. Now, here we go. So this bit here takes quite a while, because if all the joints were clean, it's nice, you can just tap the soldering iron against them and you're reflowing the solder that's already there. The problem is, what's already there is very corroded. It might well be making a contact, but it is corroded. So by adding the flux and the heat, that's going to help to just reduce a bit of corrosion, but it's really the soldering iron with fresh solder that's going to remove the rest of the corrosion. It's never going to look as good as it did when it was new, but as long as they make a contact, hopefully it will be okay. With the added flux again, it will help it flow, but they still don't want to flow very well, because you see the metal you're going onto, just the solder doesn't want to stick to it, so you have to kind of keep rubbing it against it to try to let the corrosion burn away. And it can often look a lot messier before it may start to look good. But remember, again, I'm not looking for factory finish, it's just I want the joints to look better than they did when they're all green and black. Once I've done all this, I can then give it a good clean with isopropyl alcohol again. Hopefully it's going to work. I did have to remove a capacitor because it was just in my way, because you're adding more and more solder. What then happens is you just get bridges everywhere, and then when something hasn't got corrosion on, like the capacitor, it comes off really easy when you're trying to clean the chip. So I just removed it and then I'll put that back on at the end. So I'm just going to give it a nice good clean, and then we can connect it up to a TV. I already have the Raspberry Pi iOS, or it's not called iOS, apologies, my Raspberry Pi knowledge is very limited. The operating system for the Raspberry Pi, I already have that because I've been working on some 40 Raspberry Pi sent in by a viewer and a Patreon named Liam. That's going to be in an upcoming video. So yeah, I'm going to connect up to my TV with that operating system on a little micro SD card, and we'll see if it's working or not. Right, let's give it a test and see if it's working. Okay, here we have it. So it is working. You can see it's displaying there. I've just got a bit of YouTube playing. I've got it on real low resolution just because it stutters otherwise, but I think that's just what it's like on the Raspberry Pi rather than a fault with this one here. What's interesting is, though, there's no audio whatsoever, but when I plug in the headphones, I do have audio. So the headphone jack that was covered in corrosion is actually working, but when I unplug it, it's not working. So right now, I can hear, I don't know if you're going to hear it or not, I can hear it coming through there, but there's nothing coming through when I unplug it. So maybe the headphone jack is so corroded that it actually thinks there's headphones plugged in. Not too sure. Anyway, bit of self-promotion. Check out this channel here, No Waffling. This is one of my own channels. There's not much subscribers there at the moment. I've set it up with my friend, and it is exactly as it describes, No Waffling. So there's just a load of how-to videos on there where I don't waffle on about anything. I just get straight to the point. In this one here is how to take apart and clean buttons on the PlayStation Portal, you know, the new PlayStation Portal. So you can see there it's stripped down. Interestingly, analog sticks on that are not soldered in, so you can just unplug them. But most of the videos are just, for example, how to change a battery in an AirTag, how to reset an AirTag, stuff on coffee machines, just loads and loads of different how-to videos. My goal is to have thousands of videos on there with no waffling. So none of this like, hey guys, how you doing? Yeah, well, great channel. Yeah, check me out. Subscribe. I'll just get straight into the point. Sometimes there might not even be hello or goodbye in it. Just no waffling. So yeah, check it out if you want. It'd be nice to up those subscriber numbers a little bit. I'm often shouting out other channels, so it feels quite good to shout out one of my own channels for a change. Right, let's get this board back over to the mat and see if we can work out why there's no audio. Really odd. Right, so the other side of the headphone jack has a load of points here, and this is interesting. If I go between here and here on continuity, you see there isn't anything. Yet when I plug a headphone jack into it, there is. So the jack's working. I don't believe there's a problem with the jack. I wonder, is it more HDMI? Well, that's a bit embarrassing. All you have to do is right click on the speaker, yeah, and then it comes up with two options, HDMI or AV jack. It was on AV jack and now it's on HDMI. So if you have a look here, another no waffling vid, you will now hear that the sound is coming through the TV instead of the AV jack. Hi, in this video today I'm going to show you how the touch sensor works on your Sony headset. This is the model number here. I fixed those in the previous video. Various different things by swiping and right, so yeah, massive thanks to Jake. So it just looked like it was some corrosion and it just needed cleaning up. And as far as I can see, it's working okay, but maybe there's other things on it that are not working, and maybe I'll discover them at a later stage. But it's certainly doing what it needs to do initially. So thank you, Jake. We'll go to the next song. Next up we have something sent in by Alan. It's a Buzz Lightyear toy backpack type thing. It says, please find and enclose this faulty toy which I'd love for you to tackle. Disney Pixar Toy Story 3 Buzz Lightyear Deluxe Action Wing Pack. Here's a YouTube video showing what I should do. Wingtips should light up when button pressed and wings open up and close. Should be Buzz Lightyear's voice and other sounds too. Good work, cheers, Alan. And then the back just says that he doesn't expect it back, he just wants to see it on the channel. Keen subscriber, keep it up, Al. So many thanks for that. So it is one of those things that your child can wear and then they can pretend they're Buzz Lightyear. So it's like a backpack, and I presume the wings just spring out and it will make Buzz Lightyear type noises, infinity and beyond and all that stuff. Right now, right, well straight away I can see that it's not going to work because the batteries haven't got anything on this side to connect to. So look, we have the contacts here and here, but not this side. So there's going to be no power going into it because the batteries are in series going here and here, 3 volts, but they're going here and they're not connecting, so you need to bridge them here and here. I'm not going to have any of those. Basically you need replicas of this on that side there. I'll have a look. I have got some sort of springs, but I think they're just single ones. But for the moment, let's just get some foil and bodge it up, see if it then comes to life. So just some kitchen foil. Okay, not just that. I can see corrosion, maybe corrosion's gone inside. Let's see if we've got 3 volts here. Yes we do. And here? Yes we do. Don't worry about the minus, I've just got the leads the wrong way around. Right, so the foil has done the trick, and that's not what the fault is. Let's, first things first, let's have a look in here to see if it's the button here that's not working, because I can see it's broken. Okay, some glue there that's no longer holding this in. So we've got 4 wires. This little speaker. A speaker full of corrosion. Look at that. It's all rusted through. I think this has just been left outside maybe. Because how would battery corrosion get all the way up to here? I understand the battery's leaking in here, but what's going on here? Right, okay. Let's see if that on and off button's working. I don't think it's going to be this. No way. Oh yeah, it does work. You just have to hold it down for quite a while. Right, let's take the actual thing apart. We might have to look at that speaker. Right, okay, well, the battery can't give it any power because the terminals are completely gone. So where are the wires? Right, this is one wire. We've got another one here, another one here, another one here which has just come off. Oh, this is going to take a little bit of working out. So there must be little motors just in here to get the wings to come out, so that should be okay. Don't know what is going on. There must be something going on in here in the middle. And what's this here? There's oh, and there's this thing here. There's lots going on, isn't there? So the wires come up here. Oh, maybe one links one to the other, does it? Is that what? Should it be 6 volts going into this, I wonder? Plus 6 volts, it says here. So we're going to have 3 volts and 3 volts. It must be linked together. So it goes up, down, and this is going to have to go across to here. Weird thing is, it doesn't look like there's any evidence of any solder in here at all. It says here plus 4.5 volts. This is all very confusing. Do you reckon it's tapped off for 4.5 volts between, for example, 3 volts and one of these to here, and then the other one's tapped off for 6 volts? Could be that, could it not? Tell you what, let's get the bench power supply on and see if we can work out what's going on, because it's going to be sharing the ground. Let's start on 4.5 volts and see what that does. You know, I don't know if I've seen toys where it's tapped off 2 different things. You know, you think it'd be one for 6 volts and one for 4.5, but I suppose it doesn't really matter. Or would they drain certain batteries quicker? Not sure. Right, so let's see what happens if we do 4.5 there and here. Well, I'm pressing a button and nothing's happening. Right, so nothing's happening there. Let's go on to here. I'll keep it on 4.5 just for the moment. Press the button. Nothing's happening. Let's up it to 6 volts. Hope nothing goes bang. Right, I've upped it now to 5.98. Pressing it and nothing's happening. Well, I don't know what's what. Surely when you press that button, it's supposed to then get the wings out. And these are supposed to light up here, aren't they? Let's see if we've got continuity between here and here in case the lead's gone. It might not be recognising my presses. So on the blue wire here and the blue wire here. Yeah, on the white wire. Yeah, we got it. Right, let's see if the on and off switch is working. So again, continuity. Got it there. Not here, not here, here, and then we turn it on, got it here, and got it here. That does look like a cold solder joint there though. Let's see if, positive, is that just where it's, let's zoom into that. That joint doesn't look very good. Well, I'll reflow them. I don't know what's going on there. I'll tell you what I'll do, let's undo them. You might be able to see the traces from the other side or see what's on the other side. Got a little blob chip here. Right, what's going on here? transistors, capacitors, we've got it all going on. So the switch itself is okay. I don't think that is a cold solder joint there at all. Let's go to continuity and see if we can trace. Annoyingly, the board's got this horrible kind of glue all over it. Right, so this is the negative of the 4.5. Is that the same as a negative here? Yes, it is. They can use the same negatives, can't they? And it goes into the middle of what I think is a voltage regulator, but I'm not sure. And then from there, that goes to there. So let's see what voltage we've got coming out of that voltage regulator. Well, I'm going to have nothing when I put in 6 volts, am I? I've got to put in 4.5. Right, so we've got 6 volts on the bench power supply. Let's see what we got here. I'm not going to have anything here, am I? No. I'm going to lower down the voltage to 4.5. And I'm going to swap this to here. Let's see what's coming out of that voltage regulator. So 4.5 going in. Nothing there. 3.2. So that must be running the chip, I would presume. And it goes down to here, 3.2. Okay, so if it goes down to here, I mean, that's making more sense. So that side, have I got anything this side? No, so when we, oh, there we go. When we press the button now, right, so that's doing the tips at the end. And I suppose the switches, right. I suppose the switch is also switching to 6 volts, so we need 6 volts for the motors, and we need 3.3 volts for the chip. So it looks like the blob chip is now working. Now, if you're wondering why it's suddenly working now on 4.5 volts when it wasn't earlier, the only thing I can think of is that I forcefully pulled the wings down before they were fully closed. So in opening them up a bit, I suppose I've released them from their micro switch, because there's end of travel micro switches, one to detect when it's open and one to detect when it's closed. So it must be something to do with that.
I am Buzz Lightyear. I come in peace.
Right, okay. Just takes quite a while to speak. So that sound must be the sound of the wings opening. That's what it is, isn't it? That sound's supposed to be the wings opening. So do they close automatically at the end, or do you, I suppose you press it again to close? Do you know what? Let me actually look up the video, because then I'll know whether they close every time you press it, or do you have to press it twice or something to make it close? Right, yeah, you press a button, it opens up, you press a button, it closes. And it's said that you can tell when the child is flying because it's got a motion sensor. So I presume this here is the motion sensor. So it looks like the 4.5 volt side of it is actually working. We just need to work out why the 6 volt side of it is not. So, motors. The motors I'll go to, 1 second now. These are going to be LEDs, I presume. Oh, this is the whole motor mechanism in here. Beg your pardon. The whole thing goes up and down. You see here? And these then swivel around. So this is just a pivot here. Right. So where are the wires feeding this? Is it that's just a little switch there, isn't it? Looks like there's these big cutouts here, and they look like they're on a spring, and they're going to wedge themselves into here. Right, we have a motor. Ah, okay, good. So that's the motor going up here. So it is the thicker one out of the two, which is going to here. So if we activate the motor directly, let's see if it's going to work before we get too involved with all this, because this looks a little bit on the complicated side. But you can see you have this thing here. So there's going to be all gears going on in here. This is the thing doing the move in here, isn't it? So this is a gearbox, and then, yeah, there we go. Gearbox there. I think that's all okay. I think this is an electrical problem. So what I'm going to do now is I'm going to put voltage directly into the motor, and let's see if the wings start moving up and down. I can just keep swapping my leads around to change the polarity. I'm going to start on a lower voltage and work my way up to 6 volts if nothing's happening. So I need to go just here and here. Let's go the other way. Right, okay, so that's trying to open. Let's put a bit more power in. Let's go to 4 volts. I'm just going to stand it like this, give it more chance of working. I know you can't see what's going on. I wonder does the motor need all 6 volts? Right, sounds like it's struggling, so I'm going to up it to 5 volts. I bet it needs the full 6. Still struggling. Right, so that's closed. A bit confused because that is nowhere near this. And that isn't near this. I mean, it can't close any more than that, can it? Or is it, maybe we've been misaligned. Let's try it like that. Maybe that's the problem. Oh, okay. Right, well that's fully open. Yeah, and it's locked into place there. It's quite nice the way it locks in there. So now let's see if we go the other way. I'm going to lower the voltage down because I don't know if we need that much. I'm going back to 4 volts. Right, so that's that way. Now let's go the other way. Not enough strength to lift it. Right, I'll save you half an hour of torture off listening to this motor straining. Basically, I was thinking that there was friction built up somewhere, so I was looking at the gears. I even swapped some gears from one side to the other because what I found is that the right hand side would work better than the left hand side. So they open no problem. They open amazingly well. It's just like whack right the way down. But then when it comes to closing, it was they were really straining. The only way I could get it to do it is if I kept putting the power on, off, on, off, on, off. Then eventually each time they would go about like, you know, an inch and then close. Anyway, the bottom line is it was upside down. The way this is worn, gravity helps. So if the child was doing a handstand and doing this, it's going to struggle to close these wings. But when you're wearing it and you're walking around the place, which is how it's designed to be worn, they work fine. So when they open, they kind of just fly open really quickly and then they close slower. The closing does work, it's just gravity has to be on your side when it comes to the closing. So basically, there isn't actually anything wrong with this. It just needs cleaning up. It just needs rewiring. So I suppose there was a bad battery leakage on it, and then it corroded away all the wires, and it looks like a couple of the terminals have just disintegrated and come away. Now I've had a look. I do actually have some metal terminals. I've got some single ones, so single springs, single negative, and also positive little connectors. But luckily, I also have the positive and negative together. They're a tiny little bit smaller, but they're going to fit okay. So basically, the only thing I have to do is rewire this. The only thing that makes it slightly confusing is that we got to tap off the battery compartments in different places, because each side is 3 volts, because there's two 1.5 volts in series with each other. But then we need to link up one side with the other to make 6 volts in total. But we need to tap off earlier on when it's just going through the third battery to get 4.5 volts. So I haven't actually seen that before. Not that I've done a huge amount of toys, but not to my knowledge anyway. The battery compartment is normally just 2 wires coming off that, and it's doing what it needs to do. Well, with this one, we've got 3 wires coming off it, 2 wires for the 6 volt, and then we're also using 1 wire to tap off the 4.5 volts as well, which I thought was quite interesting. And also, for those of you that are wondering why it didn't work on 6 volts previously, it's because in order to get the 6 volts to work on the motors, you have to have the 4.5 volts. So I think it's the 4.5 volts which is actually doing the switching of the transistors. I think there's 4 transistors on here, and that's like a H bridge. So it's going to be 2 transistors to make the motor go one way and 2 transistors to make the motor go the other way. And I think the switch inside of it is actually coming from the 4.5 volts. So that's the reason it wasn't working when I was putting 6 volts into it, is because I needed 6 volts going into it and 4.5 volts. Anyway, overall, this toy is a little bit sorry for itself. There's a lot of cracks and stuff in it. It's missing a battery compartment, but hopefully it will be functioning as a toy, which is the main thing. It's there to be played with. So I'm just putting new wires everywhere, adding a little bit of hot glue as well to make sure nothing falls off once it opens and closes a few times. And then I need to find someone to model this fine piece of engineering. Now this is highly embarrassing. My son's too old to model it now, so I have to model it myself. You ready? From behind? It works pretty well. And embarrassingly, the motion control does work, so I'm going to have to run around the kitchen to show you. You ready? It's terrible. I wish I worked harder at school. You ready? There we go, and lights up as well. So it appears to be working fine. Oh, that's clever. So it's every time you bend down, watch this. So you move around, it doesn't do it, but look. Do you know what? I wish I'd taken it apart now. There must be a little ball in there that drops and touches 2 contacts. I'm thinking, that's clever that. I'm not touching anything. But it stops. I wonder, does it work that way around? Yeah, it works that way as well. I enjoyed that a lot more than I thought I would do. Yeah, what a result. Do you know what? I'm going to call it a day there on that video. So a massive thanks to everybody that sent stuff in. I think it was a good variety of stuff, and overall, most things were fixable. So it just shows you a little bit of patience, and trying to do something can often end in success. So yeah, that is it. Take care, everybody. I'll see you soon. Thanks for watching.